Hi everyone, in this video we're going to look at problem solving strategies for Year 7 and 8 maths students. So I always like to start with this cartoon which says, only in maths problems can you buy 60 cantaloupes, which are rock melons by the way, and no one asks what the hell is wrong with you. And it's really true, isn't it? Because sometimes our maths problems don't have a lot to do with real life and we're still expected to do them. But what we're really trying to teach you here is the strategies to be able to solve problems that you will see in real life. So here's the steps for solving problems. Firstly, we need to read the question carefully. Then we have to decide what we're asked to find. We have to look for information that might be useful. Some people will highlight that information. We have to choose the method that we're going to use, set out our solution clearly, and then we have to check that our answer is correct and makes sense. Now before we get started, I want to talk about literacy, because literacy is really important in mathematics. If you can't understand the question, you can't answer it. And sometimes the literacy demands of a question are more extensive than the mathematical demands, like this question here. An archery team has several members who have only one leg. All these archers choose to wear a boot. Of the remainder of the 25-member team, only half choose to wear boots. How many boots are worn by the team? So my question to you is, how many members are there in the team? And it's here in this sentence here, of the remainder of the 25-member team. They could have said right at the beginning, an archery team has 25 members, but they've chosen to write it rather obscurely here. So there are 25 members in the team, and you can see how the literacy is tricky in this question. I'm going to leave you to do this question. It's not particularly difficult. I'll give you a hint. Just pick an example, like guess how many members might have only one leg and try and work it out, and you'll be able to figure out the answer pretty quickly. The other thing I want to talk about is relevant information, because quite often in problems there's a whole lot of irrelevant information and you have to sift through it and find out what's important. Here's a really good example. The school cross-country event is over, but nobody knows the finishing order. Here's what the judges said. All of this. Okay, let's get our little highlighter and highlight the important bits. Matt finished before Andy. That's important. Andy wore special running shoes. No, we don't care. Andy finished in front of Robbie. Robbie tripped at the start. Liam came first. Robbie won last year. Tim finished in front of Robbie but behind Andy. Connor won the 100-metre sprint this year. Tim ate a special breakfast this morning. I saw Robbie stop for a rest. Robbie was in the Waratah house. Connor was beaten by Robbie. So in all of that, there's only 5 pieces of information that are going to determine the finishing order. All the rest of it is rubbish. It's irrelevant. So now take those 5 pieces and see if you can figure out the finishing order. Which brings us to the strategies for problem solving. Now there are others, but in this video we're going to look at 8 of them, and they are make a list, guess and check, find a pattern, draw a diagram, act it out, find a simpler case, work backwards, and logical reasoning. Now in this video I'm not going to give you the answers to the problems that I present, but I'm going to show you strategies and start you on the way to solving them. So here's our first one, make a list, and this strategy involves systematic counting. And you have to be methodical when you write down the different options. So here's our first problem. A dartboard has the values 1, 2, 3, 4 and 5. If 4 darts are thrown and all hit the board on different numbers, how many different point totals are possible? Now think about what the important points are here. There's 4 darts that are going to be thrown and they hit the board on different numbers. So no 2 darts hit the same number. How many different point totals are possible? We need to be systematic about this. So we can start with, suppose the darts land 1, 2, 3, 4. Then they might land 1, 2, 3, 5. A third possibility is 1, 2, 4, 5. And you see how we're being systematic here? We're just going through them. Next one would be 1, 3, 4, 5. And then finally 2, 3, 4, 5. So there's the 5 different possibilities. all we have to do now is answer the question, which is how many different point totals are possible. So I'll leave you to do that. Here's our second problem for Make a List. A president and secretary are to be chosen from 12 members of the SRC. How many different ways can they be chosen? We could use the same strategy and just list them. So we could say, okay, the first person is going to be the president, the second person is going to be the secretary. Or it could be the first person being the president and the third person being the secretary. Or it could be the first person being the president and the fourth person being the secretary. And you can see already that there are going to be a lot. There is a quicker way to do this. We can ask ourselves, how many ways can we choose the president? And there would be 12 ways to choose it. Then after that, how many ways can we choose the secretary? So once we've chosen the president, there would then be 11 ways to choose the secretary. Now I'm going to leave you to think about that, and hopefully you will come up with the total number of different ways that the president and the secretary can be chosen. Our second strategy is called guess and check, and this method involves guessing the answer, checking to see whether it solves the problem, and then adjusting your guess. Here's our first problem. Place the numbers 1 to 8 in the boxes so that consecutive numbers are not placed next to one another horizontally, vertically, or diagonally. Now, there are a lot of literacy requirements in this question. What do you think are the key words? The first one is consecutive. That means one after the other, so like the numbers 1 and 2 or 3 and 4. What about horizontally? That means crossways like this. So we can't have consecutive numbers next to one another horizontally. So I can't have the 1 here and the 2 here. Vertically means this way. So I can't have the 1 here and the 2 here. And then finally diagonally, which is on a slant. So I can't have the 1 here and the 2 here. And basically what you've got to do here is just go through and have a go and adjust when you make a mistake, like here. So this is not the correct answer because I've got 7 and 8 next to one another. So they're consecutive numbers and they're vertical. And here I've also got a problem with diagonally. So let you puzzle that one out. Hopefully you can get the right answer. How about this one? A shop sells green, blue and red bicycles. If Elwood buys the red and blue bikes, it will cost $1,500. If he buys the red and green bikes, it will cost $750. To buy all three costs $2,000. How much is the green bike? So we can guess and check. We can start off with red and blue and say, well, suppose they're $750 each. Pretty quickly, unless the green bike is $0, we'll find out that that's not true and we can adjust our guess. You can also do this one via algebra. So we could say the red and the blue is $1,500, the red and the green is $750, and all three is $2,000. And we can just put numbers here until we get the correct solution. Here's our third strategy, find a pattern. In this strategy, we look for a pattern and we use it to work out the answer. And a table can be very useful for organizing the different elements in the pattern. Now, when the mathematician Carl Friedrich Gauss was 5 years old, he was challenged to find the sum of all the whole numbers from 1 to 100. So that's these numbers here. And he surprised his teachers by very quickly finding the answer through spotting a pattern. I'll give you a bit of a clue. Have a look at this number and this one. And then look at this one and this one. And the 3 and the 98 and the 4 and the 97. What do you notice and can you use that to your advantage? Here's another one. A necklace has beads threaded onto a cord. The beads are repeated in the order red, blue, black, green, orange, yellow, white. What colour is the 123rd bead? So this is a pattern. It's a pattern of 7 colours. So basically we want to know how many 7s go into 123 and then which number in the pattern we're up to by the time we get to 123. So that's a nice easy problem. You just got to do a bit of division and try and figure out what the remainder is. And here's a third problem. Here's a triangular pyramid with 6 layers made from marbles. If the pyramid has 10 layers. How many marbles are needed altogether? Keyword here, all together, so we're going to have to add them all up. All right, table's really useful for this. So here we've got a table and we've set up the layer number and then the marbles. So in the first layer, we've got 1 marble. In the second layer, we have 3. In the third layer, let's have a look at that. We've got 1, 2, 3, 4, 5, 6. In the fourth layer, hard to count now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I would think. Now let's have a look and see if we can figure out a pattern. So this is going up by 2, then 3, then 4. So this one would go up by 5 and this one would go up by 6. These are triangular numbers, by the way. You can see how they're making triangles anyway. So we could fill that in all the way up to 10 and then we're going to have to add those all up. This strategy is called draw a diagram. A picture is worth 1,000 words, and drawing a quick sketch of what's going on can help us organise our thinking. Here's our first problem. In a classroom, the desks are organised in equal rows. Henry sits in the desk that is 4th from the front and 3rd from the back. There are 4 desks on the right, but only 1 to the left of Henry's desk. How many desks are in the room? So this is just a matter of drawing up a grid and drawing a diagram and trying to figure out where Henry's desk is. And very quickly you'll be able to work out how many desks are in the room. Here's another example. This one's a bit trickier. Elliot has a pair of rabbits. The female gives birth to 4 young, 2 females and 2 males. In the next season, all of the females give birth to 4 young, 2 females and 2 males. In the final season, all of the females again give birth to 4 young, 2 females and 2 males. If no rabbits die, how many rabbits are there in total? So this one's a bit harder because of the diagram that you have to draw, but let's have a go at it. So we start off with a female and a male, and the female gives birth to 4 young and 2 are female and 2 are male. So it's sort of like a tree diagram if you know what they are. And so in our first season, which means the first mating season, we've got 6 rabbits. Now the reason it's tricky is because in the next season, all 3 of these females again give birth to 4 young. And so we're going to struggle to draw that off here in our diagram. So we're going to have to do a second stage. So I'm going to leave you there to keep going with it and see how you go. But just be systematic in your drawing of a diagram and you should be able to work out the answer. Sometimes it helps to act out a problem. And in this strategy, we can use people as characters in the problem, or we can manipulate pieces in a game. Here's the first problem. 20 people attend a conference. In the opening session, the presenter asks everyone to introduce themselves to all the other attenders and shake hands. Including the presenter, how many handshakes will there be? All right, keywords, including the presenter. So altogether there's 21 people, so that's a bit of a trick. Now the reason this is in the acted out section is because if we were in a classroom, we'd just get 21 people and we'd act it out. We'd have a look at what the mathematics is. If you're sitting at home, you probably don't have that luxury, but we can kind of act it out on paper. So here's our first person. They're going to be able to find 20 other people to shake hands with. Now the second person has already shaken the first person's hand. So they'll be able to find 19 other people to shake hands with. And the third person will be able to find 18. I think you've probably got the idea of the pattern. So I'll leave you to continue the pattern and then try and figure out what you've got to do to get the answer. Here's another one. There are 3 green frogs and 3 red frogs who want to swap places. Here are the rules. Frogs can't turn around. A frog can jump onto an empty lily pad, or they can jump over one frog of the opposite colour. How can you do it? So with this one, you can follow this link and it'll take you to an interactive here where you can actually, try it out. And it's quite a bit of fun actually, and you'll be surprised how quickly you back yourself into a corner and you can't do it. But keep going and see whether you can get the solution. Okay, we're up to try a simpler case. So with this one, this can help us reveal the mathematics that's required to solve a complicated problem. It's also got to do with breaking a problem into smaller, simpler parts. Here's our first problem. A scissors, paper, rock tournament is held. There are 450 contestants. For each round, only the winners progress. If in any round there's an odd number of contestants, then one person is randomly selected to have a bye. That means they skip that round and they will compete in the next round. How many rounds will be needed to decide on the winner? Now, the reason we've got this in try a simpler case is because that's what we can do. Let's have a look what happens when we've only got 8 contestants. So the 8 people will play each other and we will end up with 4 winners from those 4 matches. Then these 2 are going to play each other and these 2 are going to play each other, and they'll result in 2 semi-finalists. And then finally these 2 will play each other and they will result in 1 winner overall. So we've got 1 round, 2 rounds and 3 rounds if we've got 8 competitors. So can we extend that pattern to 450 contestants? Or do we have to start at the other end, which you can do and say, if I've got 450 contestants, then I'm going to have 225 matches in the first round, and work the other way. I'll leave it up to you to have a go at it. Here's another one. How many squares are there on a chessboard? So you might immediately say there's 64, but you know, that's a little bit too easy for us, isn't it? There are 64 little squares, but this is a square here, this 2 by 2, and this 3 by 3 is a square. In fact, this 8 by 8 is also a square. So this is a really good example of how to split up a problem into smaller bits. So count the number of single squares, then count the number of 2 by 2 squares, then 3 by 3s, then 4 by 4s, 5 by 5s, 6 by 6s, 7 by 7s, and then finally the 8 by 8, and then add them all up. Sometimes we're given the end of a problem and asked to find the beginning, and in this case we're going to use the working backwards strategy to find the answer. Here's our first example. I think of a number, I double it, subtract 1, then divide the total by 3. The result is 11. What was my number? So here we've got the end of the question, and we want to work backwards through these until we get to the beginning. So just before I got to the 11, I had divided the total by 3. So I want to do the opposite of that. I want to go 11 times 3. And then I want to add 1 and then halve it. And that'll bring me back to my number. Okay, I'm going to leave you to have a go at that one. Here's another one. When Jeremy gets the school bus on Monday, there are already students on board. At the next stop, 10 new students get on. At the primary school, half of the students get off. Then at the high school, 3/4 of the remaining students leave the bus. The final stop is the TAFE, and only Jeremy and his friend Alison are left. How many students were on the bus when Jeremy first boarded? Again, we're going to work backwards. So right at the end, when Jeremy gets off, there are 2 students. At the previous stop, 3/4 of the students had gotten off and only 2 were left. So you've got to think about how many there were before 3/4 left the bus. At the previous stop, half of the students get off, so you would want to double it there. And then at the very first stop, 10 new students got on, so we would want to subtract those 10. This is a harder question than the one before, but give it a go. And it brings us to our last strategy, which is logical reasoning. This strategy involves working through a problem systematically and logically. Here's our first problem. 3 girls, Angie, Betty and Clara, each have 1 brother and 1 pet. Betty has a dog. The horse belongs to the girl whose brother is Sam. If Angie's brother is Kevin and the other brother is Peter, who is Clara's brother? Now it seems very tricky, but this problem is actually quite simple. You can do it by drawing up a grid where you've got the girls' names across the top and you've got the brothers' names down the side, and you can eliminate different possibilities, or you can just think about it logically, but I'm going to let you have a go at it by yourself without giving you too many clues. Here's another one. A fisherman catches 5 fish, A, B, C, D and E. A weighs twice as much as B. B weighs 4.5 times as much as C. C weighs half as much as D. D weighs half as much as E. E weighs less than A but more than C. Which is the lightest fish? You actually don't have to do any maths with this. You don't have to work out 4.5 times some amount. You've just got to be able to try and put them in order from heaviest to lightest. So which method is best? Well, some problems lend themselves to a particular strategy. Some can involve multiple strategies, like draw a diagram and then find a pattern. Some can be done using different strategies, and some people prefer a particular strategy. But one thing is clear, the more you practice, the better you get. So give it a go.